Welcome to Renaissance Charge. I'm Rick Friedrich, and today we're going to talk about the meanings and implications of the words overunity, free energy, perpetual motion, all the good words, and resonance. Now, I'm not going to be very technical, I'm not going to try and be long-winded. But I do want to go over some points. I think people need to have things cleared up in their minds. I spent a large part of the day yesterday talking to people trying to cover some of these points, which I do in my meetings, more or less. And I think it's really important because people use these words and they kind of stack the meaning of these words and put themselves in a bind. So let's look at the words perpetual motion. So as soon as you have, I was at an expo a couple weeks ago demonstrating some of these things. And I had people walking up and saying, "Is that perpetual motion?" You know, these words get thrown around. So, what is perpetual motion? It's such a negative connotation when it comes to energy systems. It's like saying, "Are you a flat earther, or are you wearing a tinfoil hat? Are you a conspiracy theorist? Are you an idiot?" is what people are trying to say a lot of times in those, using those words. Now, it's actually, well, I don't want to call somebody an idiot, but it's actually the reverse to actually think that things aren't in perpetual motion. In fact, everything is constantly moving and has been since the beginning of creation. So that everybody agrees to. So what's the difference between perpetual motion as a negative term and the fact that everything is in perpetual motion? Well, again, it comes with assumptions and ridicule, the negative connotation. So when you think about it, so here we have an example. You can hear the vibration. The natural frequency of this tuning fork. And it is vibrating all the time. Everything is in some form of movement, several types of movements in many cases. So it's not absurd to talk about the word perpetual motion, or the phrase. And what we're talking about in energy systems, in the negative concept that people throw at these free energy devices or overunity devices, we're going to look at some of those words here. Now, I'm not going to try and do some exhaustive proof of how you should talk or what words you should use, but I want to create some dialogue here. Well, there's nobody to dialogue with in this video, but the point is we want to open the door to meaningful conversation without merely trying to shoot somebody down, is what I'm talking about. So when you think about it, if things are already in movement, then what about capturing that movement that's already operating for free? In fact, it can't be stopped. what about capturing existing movement? This is, I'm not going to use any real technical words, get into math, because I think what happens is most people, including engineers and scientists and that, who use these words don't really think about the meanings of the words, and they overcomplicate things and what I call prestige jargon. You actually can't explain the words you use to the average person, then you really don't know what you're dealing with. Now, some things are rather involved and complex and take time to elaborate, but the point is, I think everybody gets that, where you talk over people's heads and they just don't get it because you really don't get it. So I'm trying to do that. This is not something I'm some great expert in either, so I really can't use all that language anyway. And I don't really care to, I don't need to. I can do whatever I want with the energy I need to create for myself, and so I don't really need to use all the right language to describe it in order to use it. And I think that's what most of my listeners and customers feel the same way, even the engineers and that. So the idea of perpetual motion is actually universal. Everybody really believes in it when you ask them that question. Well, isn't everything moving to some extent? Well, yeah. I mean, I'm not talking about being in a solar system that's moving, being on an Earth that's moving. I'm not talking about that kind of thing. I'm just talking about at the atomic level and so forth. So if everything's already moving, like I said, can we somehow tap into the free movement that already exists? And we're not going to try and do that in the sense that I just said, where everything is moving and tap into that kind of movement. But there's all sorts of other kinds of movement that is taking place in the universe and in our world that we can capture. So, you know, one of the examples is this. So there, I am putting some energy, a great deal of energy I had to do to just light up that little LED. But there I was providing energy into the trying to see if this thing's still. There we go. There's movement. There's energy that is being transferred, and these are conventional. These are accepted. And the other one is solar, we're going to look at in a minute. So these are movements that we are providing, and we're moving into the next word, which is we're dealing with overunity, free energy, and COP, coefficient of performance. So now these words are very similar in their relation to the same kinds of subjects. So in this case, I did provide the energy to move these two generators. This is a wind generator, and this is a hand crank generator. But if we have the wind blowing, then we don't have to provide that energy. So this is really free energy. It's over unity, and it could be perpetual motion. But the question is, who's providing it? Anyway, I guess I didn't really finish the subject of perpetual motion. We'll come back to that one. We don't need to continue on that one yet. But we want to look at this word free energy. Now this is slightly different than the idea of a perpetual motion device or a Overunity device. Free energy is just simply me holding up or mounting this or any kind of wind generator or any kind of solar collector, and it's freely providing energy. That's free energy. It's not a negative word. These are words that have become negative to kind of suppress the idea of alternative forms of free energy. And there's great psychological warfare and manipulation and deception and that is carried out in order to suppress energy independence and for various other reasons. So what I'm getting at is you have to come to grips with that. People say all the time, I've never seen an Overunity device, I've never seen a free energy device. And they have. I mean, at this point, if you travel around anywhere, you're going to see a wind generator somewhere. You're going to see solar panels all over the place. So it's not a negative thing. It shouldn't be ridiculed. Oh, you believe? Like, I just turned it around, I said, well, don't you believe in solar panels and wind generators? Well, yeah, but that's not what I'm talking about, right? Well, it is what you're talking about. It's the same thing. In fact, people have used the wind energy that you can collect from the wind, since as far back as it goes, pretty much, in time. But solar, people would have said the same kind of ridicule. Oh, you can't get energy from the sun until like just 100 years ago or so. So anyway, you have this negative connotation for no reason, and it's ignorance to laugh at it or give it a negative. So we're going to talk about the similarity between these unaccepted forms of energy collection and how the rules suddenly change in regards to the definitions and the rules and everything are not allowed in those devices that are not accepted by the establishment. And those processes, I should say, or those types of free energy systems. And so suddenly laws that don't pertain to these matters get thrown in the mix, like the laws of conservation of energy don't have anything to do, they do indirectly, but they don't pertain, they're not an argument against these free energy devices. It's a misunderstanding of words and meanings and laws and science to throw those things out, because the same could be applied against solar and wind, right? Because we're going to look at that in a minute. So I don't want to get into the electron theory and all that, but that's where it's going to come down to it. If you really study that out, you realize all the arguments against these things fall apart by their own definitions. There's if you read one side of the textbook, it's going to say one thing and another thing over here, but they don't say them together, those different, or those similar ideas. But we're going to get into that with several different matters in a minute. So, what's this thing right here? This is amber. So this was very significant to really the history of electrical experimentation, and it played a big part in learning about electrical activity. So again, this was discovered, and at first things weren't believed, and then people started learning, and so that's what we're trying to be open to, is there's we can't be presumptuous and think that we, in our own experience personally or collectively in the world or in some kind of scientific body, have come to all the answers to everything. I mean, who could presume that they have everything figured out? I mean, there's quite a few people that have, and I'm just blessed to learn from them. They're an infinite source of misinformation, I guess. But you come across all sorts of things. Probably daily there's something that's discovered that's making some kind of news somewhere, and who can keep up with it all? So the idea that, well, you can't tap into types of energy, like for example solar, it's a very sophisticated process, and it's very very difficult, and so there's a lot of other types of systems like that too, that the average person could never really grasp all the details to it, or doesn't know. And so it's the same. So once in a while though, you have this body of laws and explanations. This is the only way it can be in physics, and then somebody comes along and makes something that doesn't make sense. So you've got this thing here that you spin it in one direction, and then it stops and then turns and spins the other direction. But if you spin it in this direction, that's the way it actually wants to turn. It doesn't stop and turn back. But this whole idea that it spins in this direction and comes back is kind of similar to something that all these other things that we're doing that I focus on daily and for many years now, that just doesn't seem to fit with the established laws, the rules, and it's an exception. In fact, it's not really an exception, but it's part of a bigger picture that people aren't really willing to accept, or they haven't experienced it. So, I mean, there's all sorts of theories, and it's not my point to, promote a theory, or it's my point to observe things that you're not used to and say, hey, what is this telling you? Like, I do this more on a spiritual level, trying to show people that, hey, the whole world could be wrong, and has been in many different things over the centuries and the millenniums. And large numbers of people can be wrong. So it's hard to show that spiritually, showing the idea of true love to somebody who lives in the concrete jungle. Everybody around them, everybody they've ever known is selfish, more or less. And they have never experienced true love. Everybody's heard those words, but trying to communicate that in word is difficult. But when you communicate it, you demonstrate that in various ways. It's it's hard for people to accept, but it's something that will resonate with them, to use another keyword, resonate. So in the same way with technology, it's hard for us to accept things that are different than usual, than what we're used to. So I know of many things, and I just brought some examples here to talk about. So if we have the word free energy, it's merely a means of collecting things without us going to any trouble, or less trouble than we would normally go through to get the same result. So for example, if I use a hand crank and turn this shaft here and then make the light come on, and that's what we're used to doing, then that is the norm. That's where you could apply these various laws and say, hey, it takes this much work to produce this action. So then what people have done is defined that. That's what is the universal. If you're doing this, it's always going to take this amount of energy. And that is debatable in itself, because somebody comes along and adds more of a free energy process, or this is where I'm saying the words. I'm a philosopher, so words are very important to me, but I'm also not somebody's nitpicky about words. I realize people have different definitions for the words, so I'm trying to be flexible here. I'm trying to show how you need to be flexible. So somebody comes along and shows a more efficient way of doing it, so then maybe that law may change. They say, well, under this circumstance, so then you start thinking, when you're talking along this line, about the environmental factors. So the environmental factors are very important, because you're not in a vacuum. You're not merely, there's more than just you and that hand crank and the load and the device. There's more than that. There's an environment. And that can have a really big impact. In fact, it does have an impact. And if you start asking yourself the fundamental question of where does the energy actually come from, right? I mean, this is the source charge problem for people to try and understand. Is the energy coming from the mechanical work? Like, is the mechanical turning to electrical? No, it's not actually. So what you're doing is you're creating a dipole. You're creating two poles, and the energy is streaming out from between those poles. And so you're separating charges and so forth. Now, I don't want to get too technical in this video, but if you ask yourself, where is that energy really coming from, then everything changes, and all these assumptions, and you can't do this, you can't do that, and it's fake, and it's not possible, blah, blah, blah. That all of a sudden changes when you realize that actually everything is coming from, all the energy is actually coming from processes and places. I'm not trying to be technical at all here. What you don't think of. And so people have a really, like, scientists and scholars and what have you have a way of putting everything in a nice little neat box and talking about it and limiting the possibilities by their definitions, and it's a circle argument. But they don't answer the things themselves. It's kind of like atheism. Atheists love to throw all these accusations against God or the idea of God or evil, but they have to answer the same questions themselves. And it applies to everyone. You have to answer the problem of evil, the idea of morality and right and wrong. You can't just, attack somebody else and make them answer the question and then criticize their view. You have to be answering it yourself in your defense if you're holding to affirmative position of something. So anyway, let's talk more about Overunity, or let's start talking about it. So Overunity is another negatively connotative word, and so unity means one unit, and then you either have over one or under one, and the one refers to the power or the energy or the input that an operator, a person, is putting into themselves for themselves. So one way it would be is paying the electric company to provide power, and you're inputting that power in watts. So now you're paying for that power, and work has to be done to create this. If you're doing it the old-fashioned foolish way, which is a huge waste of energy and a strain on the environment and needless waste of money to pay for electricity. Anyway, what I'm getting at is it's a unit of power, or I'm not going to try and get technical with my definition here, but it's just trying to talk in general here. You have X amount of effort to go into the production of producing this light to come on, right? But now if I reduce that to zero effort, and then I have Overunity. I have no input. In fact, the COP is infinite. I have no input at all, so therefore it's not a matter of me putting one unit of energy into it and it takes normally 100 units. It's me putting no effort into it, and I'm not talking about the effort that you take to put it up and pay for the device, but the actual effort to make the energy happen. So the point is the wind can provide that. And so the wind is, okay, so this is not a closed system. So this is an open system with the local environment. So local environment is the air and the wind blowing, just like the solar, even though it's much farther away. Actually, the sun actually relates to the wind as well, but the solar is much farther away. I mean, some people believe the sun isn't that far away, but we all agree it's pretty far away, no matter what theory we hold to. And somehow we can collect, the energy. What is that energy? And so I think most people don't even think about what is light and how is that. I mean, the people who are dealing with frequencies, they don't really understand that, the average person. But somehow or another, we're in an open system with the sun and with the wind. So that's all acceptable because it's not violating these thermodynamic laws and what have you, because those all pertain to a closed system. You cannot get more energy or create it or destroy it, so forth, within that closed system, which is an assumption. There's no way to prove that. You cannot prove that as a law. But the point is, what these two systems are doing are not part of that. The sun is an outside system, and it's influencing our solar panels very far away. So who's to say that we cannot collect other forms of energy in a similar way? I mean, like I said, it's only been 100 years since we've been doing this, not the windmill, but the solar. And this is where actually we are doing the same thing with some of these systems. But at the level of the electron, everything is doing that. And so the energy is actually coming in, not the way people really think, into these systems. And so it's just kind of, by definition, people are throwing words around. So Overunity, in another way you can look at it, that you have an equilibrium, right? You have, even though the electrons are constantly moving, and the electrons are a perpetual motion experience. If you want your smallest perpetual motion device is the electron. It never wears out. It's perpetual. Nobody believes that electron is going to wear out or has worn out. Nobody can explain how it keeps moving with nobody providing power. Like, it doesn't go to the gas station and fill up. It doesn't wear out. It doesn't, not like our bodies. Our bodies in the natural or the regular creation, or the larger elements of the creation, are accursed. Because of our sin, it was cursed, and that's another whole subject matter, but because of the curse, we experience that aging and all the negative physical things in life. But there are other things that are perpetually unchanging. I mean, I don't know if the electron has changed since the curse and the fall, whatever, but the point is everybody agrees to that. So this video is going to settle all these points and take away really the substance of all these arguments against any kind of free energy device, because when you think about it, by everybody's admission, like I said, everything's moving, the electron keeps moving. And the electron is what's powering all of our loads. How is the electron moving? How is the energy coming from that, or to the electron, and producing this action? And again, people they can use words to try and say something. That's what it is, it's just kind of words. But what can people really say? You know, I'm not a physicist at all, so maybe I'm oversimplifying things, but I think that anybody can identify with what I'm trying to say if they're willing to hear and think about it. So anyway, you have this movement of electrons, and now let's see, we'll move on to, let's see, what am I going to show here? I'm going to do the fan demonstration, not this fan, but this fan. So what I have here, and I've done a video I've done videos for the last probably about 14 years on this idea of taking a fan that's in the back of everybody, inside of everybody's computer. Now this is a bigger one, brushless motor, and converting it to create free energy. So let's go back to that word free energy now and think about it. So normally you have a circuit, and I didn't bring the diagram, but you have a battery and it's looped around the motor, and you create a circuit, a closed circuit, and therefore it drains the energy down from the battery and it charges up, or it not charges it. In this case it does, but normally, in this case, this is an unmodified one. I just opened it up so you could see inside. So what happens is you drain the energy at a particular rate. You know, this one's rated for about 30 watts, 24 volts, I believe this is made for. Yeah, 29 watts at 24 volts. And I can run this down at 12 volts too, but it's slower. Anyway, the point is that there are billions of these fans. I mean, there's probably a couple of billion computers, and there's more fans than just those computers, but they're in all those computers. And I've taken them apart over the years and I've shown this, and thousands of people have used these fans the way I've shown them, because I showed them. Now, I wasn't the first one. I was the first one to do these fans like this, I believe, but others did similar systems. I'm not trying to claim I invented all this, but I made this popular, I guess. Anyway, what I'm trying to get at is it's a form of free energy, even if it's not self-running, even if it's not self-looped. This is a very important thing, because people, and I want to say why it's important, because people mix up ideas, and they also don't appreciate what they already have and what they already know. So there's people who don't think that they're skeptics, but they really are. And they're self-deceived, more or less, in these matters, because they're after a bigger goal. So I want to say, first of all, in order for you to get, for those of you who are seeking, and I would say 95% of the people in the free energy community do not have free energy, or at least do not have what they're looking for, even though many of them think that they already have it, and they're mistaken. And I realize that, but what I'm getting at is we need to have clarity, and we need to look at things step by step. That's why I'm doing this video right now, because I realize more and more that it's not about showing. I mean, I've shown a 26-foot boat running off of a free energy device that I ran that for 3 years without charging the batteries. I've shown the big the big things, and that's not really, I mean, while that can be like ooh and ah, it's not really what people need. What they need is to properly understand and appreciate the various things. It's a psychological matter. People have to come to grips and overcome their misconceptions before they can even allow themselves to experience something. It's really strange. I mean, salvation with God is the same way. People can theorize it. There's numerous theologians who've never experienced salvation, and Christians that talk about it. People who talk about loving God, but they've never loved Him. So you can theorize, you can talk about it, you can and not experience it. In the same way with this, you can think that you're experiencing it, but you can be mistaken. and you can think that you're not experiencing it when you are. So in this case with the fan, and what I'm getting at is several different things. I'm not being as clear as I'd like to because I'm kind of jumping around as I usually do. But what I'm getting at in the one part of this explanation is that if this battery bank right here, which is 24 volts input, and this is a charging battery bank, if this battery bank is producing, is draining at a rate of 1, and this one is charging at a rate of 0.7 in relation to that, everything being equal, then many people would just say, that is, I don't care about that. That's not free energy, they'll even say, or because they're after something that is, that they don't have to attend to. But here's the thing about it. Normally, like I said, we started off with, you're just draining this battery down and you're producing so much airflow, the CFMs, you know, at a set rate of discharge, and you're not getting anything else but that load. And now, if I was, in this case, setting this up in the most basic level, I took this apart and I removed one diode, which is like a one-way valve, electrically speaking. I actually literally moved it over in the circuit, which I have right here explaining. So I take apart, you can see the coils there, and literally I take apart this diode here, and I'm not expecting you to see the details here, but I'm just pointing out where it would be. So I take away this diode and I move it over here, and then I add another one, because you've got two transistors and you're on the collectors. So I took back the flyback diode, which is the negative energy that's being shunted out and not used. And so we're charging batteries with that now. And so that's free energy because it is never used. So if you had a computer and you literally made that slight modification, which it's a small little computer fan is not really going to be worth bothering to do that with, especially if those ones are glued in there and you'd have to kind of break apart the fan to do it. But the point is, the manufacturers could easily have a port there where you could instead run an LED or do something with that energy, so the same amount of energy that's going in, you can practically produce the output, depending on what you do. Now the other circuit on the top of this is what we usually do with these, and that is more efficient, if you will. There's a higher COP with that, so it's more like 1-to-1. And there's several different modifications that we can do with that, so I'll mention that in a moment. But what I want to establish is, if I can go and charge up this battery only 70%, then that is great. Even if it was 10%, it's 10% more energy than I was ever getting. And that 10% is free because hardly anybody knows that that's even possible. And people would tell you. I mean, I went around the USA to all these campuses 13 years ago. For a year I was traveling as a missionary, and I went to the tech schools too. I talked to, reached out, gave out my books to people, students, and talked to them, and got into debates. It was a great experience. Everybody was happy. There was no negative argumentation, at least from my side. and I was demonstrating these things, and people just were they said it's not possible, and they watched it for like half an hour or several hours, and they even gave me their batteries that were at 0 alkaline batteries, and I ran these, a smaller fan, to their amazement. And so the point is people just don't think it's possible, even who are very familiar with electrical, they're electrical engineers, and they still can't grasp that. They can't accept it. So this is something very easy to show, but the point is that you first have to come to grips with the fact that it is doing something that is thought not to be possible at all, even if it hasn't come to the level that people would like to have it. Now, this is what happened my first 3 years. I was starting this in 2004, and for the first 3 years I was on these forums volunteering. I had no business in all this at all. It was all volunteer, helping people. And those first 2 years, it was all skeptics, hard hitting, boom, boom, boom. But after 2 years, nobody really could argue anymore. There wasn't very many skeptics, because there's nothing that they could say against it. Now, what they did was they changed their expectation. They said, well, it has to be 3 times the output for it to be acceptable or whatever. It was like, wait a second, I thought it was 2. And so, the rules just keep changing, I guess, to suit the agenda. But anyway, the point is even if it's not 2 times output, like here we have the mechanical is 1 output and the electrical is another. So there's the 2 outputs for 1 input. Now in this case, because I only have just added the extra diode and moved it around, I'm not getting as good as results as I could. But my point in this video isn't really to say how to improve upon that, which I can say in a minute, but to show that 70% is amazing. I mean, that is self. You have to come to grips with that. And I don't think anybody really tried to draw attention to those facts in the free energy movements. Any kind of teachers on the subject kind of didn't force the public to come to grips with that and these kinds of misdefinitions. Everybody's trying to be too technical or too sensational. And I'm just one of your down-to-earth guys that I can see you probably fall asleep at this video right now. But nevertheless, for those who have ears, there's a lot to learn. Even though some of you know this stuff, you've got to really hear it, and you've got to share these things to others if you are talking to others about it in the right sequence. Because if you just go right for something that's more extreme, it's harder for people to accept. Now, it's not extreme, but more sensational, I guess is the word. So, now the difference is, and this relates to what we're getting at here, I'm going to show 2 examples again. And I've shown a lot of these things before, but this video is to kind of move through various levels. So if I was to add this gate driver, this is a MOSFET gate driver now, and replace the transistors with MOSFETs, I would have a much faster rate of change. So I would have a very sharper square wave turn on and turn off. So it's the changing magnetic field that gives you the goods, if you will. It gives you the power, not the constant current in a transformer or in these kinds of processes. But it's the speed of the change that is also going to determine the intensity, the amount of power. So you have to have a changing field, and the faster you change it, so in other words, the faster you turn that switch on and the faster you turn it off, the more power you're going to get. So we're going to see that here, and I've shown this before, where we're using the frequency generator to power this coil, and we'll see on the oscilloscope the waveform, and then when I add the gate driver, it's going to go off the charts. I'm going to have to use another probe that is 10,000 volt probe to be able to see on this oscilloscope. And that's all because the rate of change has changed in this gate driver. The amount of energy is not any greater, but it's this quickness of the switch. So the same way with this, if we create a faster switch, so the three ways to make this fan, for those of you who have it, the one way, which is what I just explained, was just changing the diodes around. The second way is to replace the whole circuit altogether, this whole green board, and now you're creating your own circuit, and you use one of the coils as a trigger coil. And that gives you almost one-to-one charging, depending on the size of your battery too. A bigger battery will receive more energy, and if you incorporate rest periods into this. But the more ideal way, which I don't provide this because it's a lot more difficult, I unwind one of the coils and then I rewind it with two wires, a bifilar coil, two wires in parallel, and one of them is the trigger coil, and I have to cut one of the motor coil a little bit short because there's not enough room. So that's a lot harder to do. You've got to kind of file down the edges here so that it doesn't scrape the insulation off. And I used to do that. And that will give you a much better result. So it'll give you a sharper rate of change than the other two ways, and you have a very abrupt turn on and off. So those are the three ways to do the fan, and you can add more or less transistors in there as well. So there's a bunch of combinations of things that you could do, and you could replace that with MOSFETs and drive that, because they have Hall sensors in there. Anyway, my point isn't to show you how to improve on things. My point is to show you the subtle distinction. So now I want to say this too. If you consider what it takes to charge a battery, how much energy it takes and how much energy you can get out of it. So if I take a battery here and I charge it and discharge it 10 times, and I'm measuring the input energy with the amp meter and figure out the volts and the watts, the total amount of joules, whatever unit that you're going to look at over time, and with each cycle you've got stability between that's why I'm saying 10 cycles, so you really know what your battery's doing. So then you measure that, and what do you find? It's not 100%. You have losses, especially if you're charging and discharging it faster. The faster you charge and discharge it, the more losses you incur, because on the electrical side of things you always have losses, right? On the magnetic side, though, this is a big part of this video that I'm going to move into. The magnetic side, there is no losses, and that's the side that you want to focus on, and that's the title of this Don Smith book that I put together this year, Magnetic Resonance, because you don't want to focus on the electrical resonance, you want to focus on the magnetic resonance. But anyway, what we're focused on, I just lost my whole thought there. Getting too off on my little tantrums on these different subjects. So anyway, we were talking about, well, at least the batteries, we'll go back to, the charging of the battery, that's right. So we have the charging of the battery, and if we have 70% of the energy out of this battery, we have to consider that it actually takes more energy than we're usually allowing in our calculations. So in other words, we have to admit the losses involved in that. So if I get this battery swapping around with this battery in one of these kinds of arrangements where this is just continually rotating, like I did with my boat, and I did with fans for years, I did with numerous motors. I've done this with hundreds of motors, whatever size. I've made thousands of motors for other people, but for myself, I've done so many prototypes. But anyway, it's kind of nice to have it just 1-to-1. But when it's 1-to-1, it's really like 1.5 to 1, because when you calculate how much energy it takes to charge up a battery, and then the losses you incur when you discharge it, in order for these things to rotate, I really have to have 2.5 times the power, because I have to overcome the losses, I have to power the fan, that's my whole goal, obviously, and I have to be able to maintain the rotation. So when you think about 1-to-1 is really 1.5 to 1. So it's a COP, in this case, of 2.5. You know, so you provide one input and you've got 2.5 times more output. But you're not usually calculating your losses. For the average person doesn't do that, but I'm the guy who does this all day long, and for 14 years now, 15 I guess now. So that's what you have to consider, that those details, acknowledge those details. And some people say, well, I don't really care, I just want to not think about it, plug it in, and that's fine. That's not for everybody to think about these things, but for those who are into this, you got to acknowledge that. So Overunity, let's talk about that a little bit more in a different light. If you have equilibrium, and you, like in your body, that's the best way of understanding equilibrium. You have all these chemical processes that are trying to create equilibrium, homeostasis. They're trying to create the most optimum environment with a changing external environment and an emotional environment, a abusive environment many times. And so all these incredible, absolutely incredible mechanisms that God put into us in designing us creates this incredible attempt to stabilize everything and bring it down to equilibrium. And it's the same thing electrically with the electron. It wants to go back to the ambient. It wants to go back to a state of rest. And so anything that disturbs the electron is actually overunity. It's not overunity unless, in many people's definition, unless you are, tapping into that in some way. It's just kind of like if a tree falls in the forest, does it make a sound if there's no one there to listen to it? In the same way, if there's energy being produced, like for example a lightning storm produces enormous amounts of energy and you can collect that energy, but if nobody's collecting it, is it overunity? Is it a form of energy that is used? No, it's not being used, but it's still there for the taking. So that's what you've got to wrestle with, those kinds of words and definitions and meanings. But any kind of electrical process that we use, whether it is a closed loop, constant current, wasteful energy system, it's still over unity, in the sense that the electrons are being disturbed, and they are producing results that we can benefit from, even if we're wasting all of the energy needlessly, which is what's happening in our world, in our systems. So that's the way you've got to look at it backwards. In fact, everybody is looking at it backwards, and you have to look at it the right way. So you can go back to, the original electron theory of things, and it's all there. I'm not saying something that is not in the textbooks, but the textbooks are deliberately misleading in some places to draw your attention away to these most basic fundamental facts of electrical engineering and electrodynamics and what have you. So when you have a disturbance, either magnetically or electrically, you have overunity. Now this is my use of the word overunity, and it's maybe over potential, over energy. These are kind of synonymous words with me, and I can be very precise, but I'm speaking in a context here, and it may not be the way you want to use the words, but I'm trying to say this is the way. I'm not hung up on the words. And when I talk to somebody, I'll walk with them in their definitions and try and create correspondence where we really understand each other and we don't get offended by words and miss the meanings of each other. So the point is, when you have a disturbance, then you're creating quite a ripple in the whole area, the whole environment. In fact, some argue the whole universe. When you have a dipole, that it actually, and that's not my point to get into that kind of physics, but that is actually the way people explain it. So when you have a disturbance, you have an action upon electrons that produces a result. And so it's like putting a sail up in the wind, and now we can move our boat, right? But if we ignore that electron or that wind blowing, we're not going to benefit from it. It's still there. Now we could do something to create the wind, like I did here. Create my own wind. Right? But we could do that a lot easier, because electrons are easy to manipulate. Now, this is where it gets really important. Of course, this is where it's all about that in this book. So we'll return to that subject after I get into resonance, because resonance is something that you all have familiarity with, even though you might not think about it with that word. So here's the example of resonance. So what we're going to get into is something that vibrates, and we're going to something that vibrates at its own natural frequency, which we are going to assist with very little effort in making it vibrate quite violently, if we want to, with very little input. And we have a COP that could be in the thousands very easily. So acoustically, in the audio world, in the music industry, everybody recognizes overunity in their musical experience. and I have a musical family. My cousin is supposedly the best trumpet player in the world. I've got cousins that are in philharmonic orchestras in Europe, and very musical family. So it means a lot to me, that subject. But I played the piano as a child just for a little bit. And if you put your foot on the pedal of the piano, I forget which pedal it is now, that lifts up all the dampeners, and then you hit, so they're all free, all the chords, all the strings. I was going to say wires. Someone's thinking of wires, but the core or the what was I just saying? The strings are free, open, and you hit middle C, boom. Then you'll have 3 strings, and the 2 other ones right beside the one that you tapped will vibrate for free. In fact, you just hit it once and all 3 strings will vibrate for quite a long time. And also most of the other, all the different harmonics with the other strings will vibrate for free as well. And then the whole design of the piano, the whole wooden structure, is really meant to enhance that, just like this piece of wood. So you can't hear that as much because it's dampened. But that is more isolated, so you can hear this one more. So the piano is something that most people have experience with resonance in without really knowing the word resonance. They know that this thing vibrates on its own and there's no electrical, no other input. So it's an amazing experience as your body feels the effects of that, and there's so little input into it. You know, you still can't mimic that with electrical simulation. There is something in the resonance that you really can't do electrically in the same way. But anyway, that's very important because that's free energy right there, the multiplication. And so we have that right out of, you know, the ultimate standard of all things is Wikipedia. And here we have the bare statement right at the very beginning of resonance. The first thing they talk about in mechanical systems, well, also in electrical, but in mechanical systems, resonance is a phenomena that occurs when the frequency at which a force is periodically applied is equal or nearly equal to one of the natural frequencies of the system on which it acts. This causes the system itself alone to oscillate with larger amplitude than when the force is applied at other frequencies. So when you hit that fundamental frequency, it will oscillate on its own, just like ringing a bell, or like I did with this. It continues. I hit it once, and it's going to continue on. And you could put it in a vacuum and run it for hours. You could actually have that ringing for hours, because it's the air that's dampening the oscillation. But when you add up all the oscillations, well, they're all running for free. You paid only once for striking the bell, and then it keeps on oscillating for free. So that, no doubt about it, I mean, it's something that we all experience from time to time, whether we want to or not. And we take a glass, water glass, a glass container, and accidentally hit it, and it will ring too. So, but electrically, they don't want to talk about that very much. They're not going to want to admit that. Like they said, in mechanical, well no, mechanical and electrical, it's the same thing. Because it's just another frequency, you know, it's just that in most electrical, they're doing this. We dampen it on purpose so that you have to pay for your electric, or because we want to avoid some of the hazardous spikes that could destroy the circuitry. So it's a convenience thing to make things safe, but it's beyond that. It's to keep you a slave, paying for your energy. So anyway, the resonance, by definition, is a game. So, like I've quoted this before, if you look in all your textbooks, it will say this more or less. This is going back to textbook from the 80s, and it was republished 2000, Basic AC Circuits by John Clayton Rollins. And on page 459 he says, he's talking about the Q, the quality factor of a circuit, which is really what you talk about, when they normally bring it up, they're bringing it up as focusing on the bandwidth in tuning into radio stations, whether it's a narrow band or wide band, and they're dealing with the Q factor in relation to that. But it really is actually a multiplication factor. It's the amount of gain that you're going to get. This is the amount of overunity you're going to get out of the system. And so it's really, what's really odd is that this is one of the most basic, one of the most widely known things in electrical study. Like, you all have to study this. Everyone has to study this when you study electricity. So the Q of a circuit, period, is just a kind of heading. A circuit is sensitive to changes when used at the resonant frequency. This is determined by the Q, or quality factor, of a circuit. And then he ends the whole thing calling it voltage magnification on page 459. Later on page 460, next page, at resonance, the voltage across the inductor, so here's your inductor, the voltage across the inductor will be Q times larger than the applied voltage. So we're going to look at the voltage here, right? And we're looking at 9 volts input. So this is my oscilloscope measuring the waveform. This is the frequency generator creating the frequency. This is the power supply providing the power. Well, in this case I'm not actually using this yet. I'm just using the frequency generator, which is 10 volts. No, 6 volts. 6 volts input, that's what he's talking about. So the voltage across the inductor is going to be Q times larger than the applied voltage, which is, what did I say, 6 volts. So what's the Q times larger? And he says this is determined by the Q, or quality factor, of the circuit. Voltage magnification. Oh, sorry, that was the last paragraph. At resonance, the voltage across the inductor will be Q times larger than the applied voltage. This is referred to as the voltage magnification in a series resonant circuit, and Q is sometimes referred to as the magnifying factor, page 460. So a series circuit is an inductor and a capacitor in series with each other, and on either end you're connecting up this frequency generator. So now I have 160 volts peak to peak. So 80 volts up and then 80 volts down. So I have a multiplication of the energy. This is only 5 volts peak to peak too. So I have a magnification of energy. 160 divided by 5 is my Q factor. Now that is real gain, and I'm going to explain why. Like here's the receiving coil, which is this is the transmitter, and that's not really important at this point. But the multiplication of energy is real. Now people say, well, so the input voltage has gone up, but guess what? The amperage has stayed the same. So the amperage coming in through this red wire here, the input amperage is the same as the circulating amperage, but the voltage has gone up. So volts times amps equals watts. So in this case, if we have, well, we'll show with the power supply in a minute when we use the gate driver that we can run this at 21 milliamps at 9 volts, and we're going to be doing a 1/4 watt. And then if the voltage increases while the amperage stays the same, then we have real extra power. And I'll come back to this point, but I want you to know that in this case we're not using the power electrically. That's the key point. We're going to be using the extra energy on the magnetic side only. We don't want to detune this. We don't want to load it down. We want to create a big magnetic radiator. We want to transmit radiation magnetically, because magnetic always equals electric. So we'll come back to that in a minute. First I want to just say the magnification factor. So what we're going to do, just to show you, we'll come back to this, now we're going to connect the frequency generator to the power supply, and we're going to run this oh, and guess what? Suddenly we went up to 700 volts, and I'm at, well, 9 volts. So if I change, I can go up and down, and now I'm off the chart. I can't even see it. I'm about 1300 volts. Of course my amperage went way up on that one, but I don't have to go way up. I can go down here. But what I'm saying is I'm using the gate driver, and now I'm getting greater output because it's a sharper, like we talked about before, it's a sharper on and off time, so which is creating a faster changing magnetic field. And we can do that for the same amount of energy as this frequency generator, and we're just improving the process. So that's a big theme in this book. All the themes are in the title of this very long title of my book that comes with this kit, and the impedance phenomena, which Tesla talked a lot about. So anyway, going back now, that was a series. This is a voltage amplifier with the series arrangement, and now we're going to look at current magnification, where the voltage stays the same. It usually goes up a little bit, and the current is amplified or multiplied. So page 470 now, 10 pages later, after all the equations and all that stuff that you talked about in the book, current magnification. At resonance, the current through the inductor will be Q times larger than the total current. And then he says later on here, this is referred to as the current magnification in a parallel resonant circuit. Q again is known as the magnification factor. You may find this unusual, but the current expressed by equations 1445 and 1446 is much larger than the inductive and capacitive branches of a parallel circuit at resonance than the total current. And then later on he says, although the circulating current is large, the total current drawn by the circuit has a minimum value at resonance. So the total current is the input current. It's misleading to say the word total. It's really the input current. And he doesn't say that the voltage stays the same. In most people's mind, like I talked to somebody yesterday, and they thought that it was like a regular transformer. Transformer, when you have, stepping high voltage down to low voltage, you're going to have a change of voltage and amperage correspondingly, where you have the watts here equaling more or less, well, usually less, than the watts in the final. So you have, 100 volts coming down to 10 volts, but the amperage is going to go up. So you still equal similar watts. In this case, it's not the same, but they're not drawing attention to that. So with the series circuit, the amperage stays the same from the input, but the voltage goes up at the Q factor. So in this case, we're having about 144 times more energy output than input. This is a COP of 144. Pretty much. And that's with deliberately low Q capacitors, so that it's safe. I mean, when you're working with 1300 volts on this kit, you can get a real RF burn, like you're holding this neon bulb, and this is not even grounding the system to get more energy or doing quarter wavelengths or anything. And I, can really burn myself with that, because I could be up to, I think, 23.5 watts on my transmitter for only quarter watt input. Or when I do the bigger coil at my meetings, I'm actually going from 3.6, 18 volts at 200 milliamps, 3.6 watts to 900 watts in the transmitter. The circulating wattage, if you will, would be 900 watts if I'm at 4,500 volts or 5,000 volts, somewhere around there, depending on how I tune it. And the transmitter, in that case, you can feel within 10 feet, you can really feel the fields, and anything lights up there pretty powerfully. So you have really like 900 watts of transmission there at 180 kilohertz, whereas this one's operating at a higher frequency. This is 1.25 megahertz, and that's the limit of this gate driver at 9 volts. So anyway, that's the circulating current and the circulating voltage, and it's real amplification, just exactly like a piano shows that. So it amazes me how people can constantly say, well, you can't get more out than input. Well, just sit down at a piano and tell me that. Well, it's different. No, it's not different. There's no difference whatsoever. In fact, there's a lot more dampening factors in a piano than there is with these types of systems, electrically speaking. So, okay, so I wanted to say those points, and Um, so now we're going to look at and think about wave propagation. So we have a number of things to display here. So we have these plasma tubes and bulbs, and I'm not going to show them being used to produce energy, but they produce enormous fields around here. So I have it's pretty bright in here because I have a really bright light on. What am I doing here wrong? So I have here kind of a mini spectrum analyzer, very good product here that for just over $100 saves me $24,000 because it gives me everything I'm looking for in a meter. It does the EMFs, EFs, and RF. So we're going to look at EMF right here, and from this far away, I don't have anything else on right now. From this far away, we already have 1 milligauss, which corresponds to the potential of 100 watts of potential energy that you could create from that magnetic field if you know what you're doing. So we're going to go closer, and now we're at 35 and it's saying high. This is high magnetic field. So when I get to here, I'm going to show you where 100 is. It's extreme now. So it says on the screen, extreme. It's 100 milligauss. So you can measure magnets and all that with this, but so now we're 200. Let me just show it on the side here. So we're at 300 milligauss. I mean, this thing is running off of some real low voltage. I think it's 6 volts, and it's very low power. So we're at 300. Now again, if I go right about here, I'm not at all affecting this. I'm not changing it. It's not concentrating over here. It's not transmitting from there to here only. It's transmitting 360 all the way around. So you can multiply that. If you can understand how to create a collector, you can collect this just like we do with this kit all around, right? Now this is, I know this one is 28 kilohertz because I do a full demonstration of this at my meeting. Well, actually not a full demonstration, but more than what I'm showing here, because I don't really want to get into. So right now I'm already at, so I'm about 1 milligauss out here, so that's like 3 feet away about. And now I'm going to move closer. This one takes 8 watts to run. So now it's telling me it's high. So we're at 300, we're extreme, of course. And now it can't, it's telling you the EF is high and the RF is high, because it's got 3 different meters in here. So it's extreme power, but that's a very high magnetic field. And nobody's thinking about it but me. Well, Don Smith obviously did a patent on it, it's in the book here. So there's a lot of radiation coming off of that that is not being tapped. So I showed 2 different ways that you can tap that energy, which is in the book. Don shows that. And that, whatever energy you collect off of that, while you still use it for its purpose, I'm not affecting, when I'm collecting that energy, if I'm not right up against it and touching the glass, I can take all that energy that it's producing and use it. So the kids want to play with it or look at it. I could put collectors right at the bottom here and right at the top without affecting the purpose of that. And I could collect, if I know what I'm doing, and create a resonant grounded circuit, I can really pull a lot of energy or create a lot of energy, far more than 8 watts. And so, and in fact I could stack all these plates up here and they're all independent of each other. And they're all collectors. And I've showed some pictures of that before, and that's why I show at my meetings. Well, anyway, the point is, this is radiation. So what is the radiation that we're talking about? So pulling this out of the closet, the kid's toy. So here you have 4 waves. So you've got 2 sine wave here, and hold on. If I turn on the lights, you'd see it more because I could speed it up or slow it down. Now we've got 1.5 sine wave. So there's your waves there, right? So that wavelength would be, let's see, that would be in the megahertz somewhere. The wavelength will be what is convertible to frequency, and it's all on this chart here, this big chart. It's got the whole electromagnetic spectrum, all the frequencies. So if we're dealing with light frequencies, we're way up there. We're dealing with like the infrared to ultraviolet, and the solar's in that mix there. And we're talking about trillions of cycles per second that are going into the solar panel, and we literally have like the equivalent of a coil. Just like this coil was receiving the waves here that were traveling in a wavelength that is over 1 million times a second, 1.25 million times a second. The light waves that are just like those waves you saw there are coming in trillions of times. That's how fast it is, and they're very small. So, anyway, I'm not going to get into the details of that, only trying to get at the point where we create waves all the time. It's so much technology. So this right here is a magnetron, and it's not a transformer toy. It's actually very dangerous, and you really don't want to deal with that because it could be very very dangerous to you. Obviously, if it was exposed while it was running, that would be producing some very bad radiation. And so I do a demonstration in my meetings, not of that, but I take a antenna. It's a dipole, and it's 1.5 inches or 1.25 inches long on each side, and it will light up an LED in the presence of that wave. So if the second last meeting I had, one of the guys brought their microwave ovens down from their rooms because I asked them, and we were wanting to look at whether this microwave was leaking, and you'll always see this light up a little bit. Once you get to 4 feet away, it shouldn't light up at all, and that's why people say stay at least 4 feet away from your microwave. Well, I walked back like 25 feet and it was still lighting up as bright as ever. It was like the microwave didn't have the front door on it. And everybody got real nervous, and we're like, let's shut this thing off because we're getting nuked here. And anyway, that was a very small example of wave collection. Now, it wasn't anything more than trying to be an indicator, but it's the same thing as collecting energy from the sun. There was a very small solar panel, if you will, at a set for a much lower frequency, just like this is tuned to this transmitter, right? So if you're running an appliance and you're collecting energy off of it that nobody ever collects off of it, and you're not affecting the appliance in any way, that's free energy, right? You know, it's like putting a sail up in the wind. But if your sail is this way and the wind's blowing this way, that's the way we're actually using our electrical systems. Only a little bit of the wind creates a resistance across the sail. And the same way with our electrical wires, the energy passes this way and only a little bit collects into the actual circuit itself. So the vast majority of energy is not being collected. Just like this, if I put perpendicular to the dipole, it's going up and down 28,000 times a second. And I can collect that energy that is the heavy side flow at the right angle. But nobody's doing that. Or very few people are. People don't even think about it, they don't know about it, because they don't really care most of the times. Like I'm talking about those who design the circuits that we use and everything. So you could take a lot of different things. If showing the microwave, you wouldn't want to do the microwave because it's too much energy, it's too dangerous. You don't need to go that high. And don't do it, please. Don't even think about it. I had one guy tell me, oh, I like to get the magnets out of those, and his face was all just, no, I'm just joking. Radiation poison, I was joking. It's no joke. But you don't want to deal with exposing yourself. So that's a big thing that I like to talk about, obviously. But you have all these waves, and this is showing you on this page here all the different kinds of waves going from the very low, extremely low frequency all the way up to the unknown, past the gamma rays. And so everything has its own natural frequency. Even magnets have a very high frequency that you could tap into. Or some people condition the magnets at a certain 60 hertz frequency so that they would be in resonance at 60 hertz and put out a 60 hertz radiation. When they're triggered by 60 hertz, then they're going to really vibrate and put out more power. And so that's all the same kind of thing here. It's nothing really spectacular. That's why we did this kit, because I've realized that people don't know these basic things. How many maybe millions of electrical engineers around the world have studied these things but don't even realize what they've studied? The most basic elements of their study, the electrical and magnetic. So going back now to the electrons, so when you, here in this case, well actually let's look at the motor first. When I electrically pulse the motor, two things happen. First, there's a magnetic response from the electrons. The electrons spin, and they give off, when they're electrically pulsed, they give off equal units of magnetic impulse output, and then 90 degrees later they give out an electrical, and they're always equal, the electromagnetic. So when you have that, you push the motor, right? In this case, you push the magnet, and I'll leave that on here. So you're pushing a magnet, and then there's this electrical impulse that nobody pays attention to. And I use that to charge a battery, like we talked about. Now on a generator side, the same thing happens, but opposite. When you magnetically impulse a generator coil, which is exactly what we're doing here, but on a really high frequency. So I'm magnetically influencing the coil, and the first thing that the electron gives out, it's like you've prodded him, and the electron's like, ow! And the first thing he comes out of his mouth is electric. He like vomits electric or burps electric. Ow! And then 90 degrees later, turns his head 90 degrees, and then he shouts out a magnetic belch. So it's the opposite sequence of events, but you have two outputs for one input. But nobody would think to do anything about the magnetic side of the generator coil. In fact, the way they make the whole system prevents it from benefiting from that way. But you have two outputs for one input if you do it right. And that's not even in resonance. So there's the electron spin is going to give you two outputs. But this is the basics of electromagnetism, is it's both electric and magnetic, and they're equal. So when you have a certain magnetic flux that we're looking at here, it is equal to the electrical side. In other words, we can convert that magnetic. It's not that we're converting magnet to electric, but we're spinning other electrons. So if we have a magnetic field or magnetic wave or magnetic ray, and it is going to influence electrons at a distance to spin. And if these spin, they will give off first electric, then magnetic. So that's the key, the secret to these free energy devices, starting with the solar panel. Let's not get all upset about this, because it's the same thing with the solar. I'm putting up a collector, and it's not really a collector the way you think. It has its own electrons. Electrons aren't coming from the sun and being absorbed by the solar panel. Waves are propagating in which spin electrons, which then are in the right collectors, if you will, the right medium, to be able to process that spinning to create electrical charge. But it's all very simple in that way. We don't have to get into all the complexities and use all these fancy words and talk about quantum this and whatever. You know, all we have to understand is that you have electric and magnetic, and I mean obviously there's a lot of math and doing all these things, but for the average person, they don't need to know any of that. They just need to know that really there's two sides of it, and we all know that, but we don't necessarily think of it. We don't think about it as equal. So and I say this all the time in my meetings, that if I have my if you have glasses and one lens saw all the magnetic relationships of everything, and the other one saw all the capacitive relationships, you'd be laughing, and you'd be frustrated, you'd be angry at how crazy we are in all of our systems, and all this wasted potential. So you laugh at the skeptics and the people who say, oh, you can't get this and that. When you see, like this is using those lenses right here, right? So, it's showing you how intense that magnetic field is. But if you don't realize that you can collect that or utilize it, in fact, it's only influencing the electrons to spin. The electrons aren't coming from there to here and being absorbed or swallowed up or something. They keep on, the waves could keep on traveling past, like a crystal radio is something I've talked about. We provide as an option for this kit. You can convert it to a crystal radio. Crystal radio has its own electrons, and it really only works well when it's connected into the ground, because the ground is a great source of electrons. So what happens is the waves are coming from the transmitter of the radio station, and they're also coming through the ground too. And that's what we talk about in this book. But they're coming through the air, and there's just a very faint signal. And so what happens is, it's a resonant circuit. It's tuned to that frequency. That's where you hear the particular radio station you want. You're tuning into the resonant frequency. And so now, this coil connects to the ground. And what happens is it's pulling electrons from the ground, and more electrons are spinning, and therefore producing an amplification of energy. And so, before they're connected to the ground, they're still grounded by an air ground. Or if you connect to a plate, it's a higher source of electrons than the air. So it's going to give you more amplification. There's a vast difference when you connect to the ground. You'll see that you can't even hear anything without the ground connection with the crystal radio. And so that's the theory, the idea that you're pulling the electrons from the ground, they're spinning, but you have this twofold aspect where this receiver is also a transmitter, because while it is producing electrical output, it's still producing a magnetic output every time it oscillates. So every time it flips, it's going to create a magnetic field of its own. We get into that where we create a sympathetic resonance, where we could actually, I demonstrated this in California, where the transmitter was being powered by all these receiver coils in a nice locked relationship where I could really load it down and nothing was happening. It was such a sympathetic resonance where you have the phase conjugate mirror, to use some fancy words, where what's happening is the transmission is mirrored, and then it is in phase to send back the same power. Well, it's got its own power, so the original wave can continue on, but this one, in its right phasing, remember it's 90 degrees after, first it will receive the magnetic, and it will convert to, it will create its own, in its spin, its own electrical, and then 90 degrees later it's going to produce its own magnetic wave, which then can go right back, if it's got a nice good Q factor in there, it's got its own amplification system, then it can actually propagate back, and you could actually lock into each other where it's just the same thing as a tank circuit that's increasing, just like those bridges that collapsed where the people were walking, or the collapsing Tacoma Bridge in 1941 or 40, I think it was, and then in 2000 the London Bridge, where people were walking and they were in resonance with the bridge, and they kind of got stuck walking. They were forced to do it. After a while, it got so strong. It was like psychological lock too. But anyway, the point is, the lock-in effect could take place. But this is all stuff that you can't see with your eyes, and we're not familiar with it other than like a radar gun. This is what we all know, that the cop sticks the gun out at us as we're driving. We get a nice nice bath of 10 gigahertz of radiation pointed at us, and it bounces off of the car and is received back, and you can tell your speed. Now, you could collect energy in that whole method too, quite a bit of it. So what I'm getting at with all this is, it's actually quite absurd and silly to doubt all these things, because this is in all of our technology all around us. Pretty much the average American home is going to have quite a few devices that are using all this waves, especially with your cell phone, which you need to get rid of. I gotta get rid of this and go back to landline. Get away from all these waves, because they're not good for you. So if you're going to do a system like this, you want to fully shield it so that you're not being exposed to it. Because we'll even look at this kit now, and so we can see here, it's extreme. We're already up to 400 milligauss, and I can turn this up. Oops, wrong one. Really crank this thing up to 200 milliamps. I mean, I could go quite a distance away from here, and this is all lighting up. So it's quite high, the RF, the EF, and the EMF. And actually, this oscilloscope partly detunes it from this one. Anyway, I turned this all off, but you can see again the waves. These are 100 volt divisions, so it's way off of the screen here. Like I said, it's 1300 volts. When I get my other probe here, the real deal, the 10,000 volt probe, so you've got a lot more propagation here, but it's at a higher frequency than this was. This was lower frequency, but it was more intense, more amperage, so to speak, than this. This is like, I was running that one up to about 1 watt or so, maybe 1.5. So what I wanted to share is all those things, and I think I covered most things. Oh, yeah. So a couple more things here, if we go back to this. So now, one way to, what we got to realize is, this is at a high frequency. So I'm using a ferrite rod here, and you can see it's actually lowering the power. It's kind of detuning it, because I'm doing it on the transmitter. But we can run this be bright, but this is not rated for high frequency. So these diodes in there aren't high frequency diodes, so they're going to be really cutting off all the power potential. Now this is a 3 watt or 3 or 12 watt LED, and it can handle quite a bit of abuse. So, and same with these little LEDs, they work really well. They don't blow out like most LEDs. So in this case, I'm going to show the transmitter coil. Oh wait, I just did that backwards. And my goal isn't to show all this stuff, but I want to talk about a few things here. Because the ultimate problem is people don't know what to do. So you can see here, well, let's turn off the, let's tune this a little bit better here. I'm going to change the frequencies a bit. See, the oscilloscope kind of detunes it a bit. Now I gotta find it again. It's either lower or higher. I guess it's lower. Well, maybe something happened here. Somehow. Huh. Wait, here we go. I think I might have damaged it, but so if you get in line with it, you can power these lights. But what I'm getting at is that the frequency is too high for this application. You can show the basics of it, but you're talking about 1 megahertz here. And those diodes are for, you know, they're not going to get up more than a couple hundred hertz cycles before they start not working properly. And the LED can only respond itself so much. So if I have, in that case, about 23 watts circulating between the 1300 volts and the 200 milliamps, even though this input voltage is only 9 volts, if I have you know, that much, that's all radiating out in all this direction. If I'm not like touching it like this, or inside of it like this, where it's, that's kind of the ideal system, which is what we're going to do next with this kit, is put a inside primary, and that way it's getting the full magnetic intensity, full intensity inside of it, or we could wrap it around, but we won't do that in this case because of the way this is assembled. So the point is that if you can figure out how to collect it and then change the frequency to a usable frequency, you can do that with so many things. So in the end, all these free energy devices almost are unnecessary, because all you got to do is create collectors like solar panels, and they're not as complicated as solar panels to do, especially if you stay in the lower frequencies. I mean, you can do that with 60 hertz as well. It's not going to be as good, because as the frequency goes up, so does the amount of energy, you know, and they're actually obey not just the square laws but the cube laws in that way. So the amount of energy cubes, you know, as the, you know, Fibonacci equation. So what happens is, like I said, we can collect the magnetic side and convert that to electric, so to speak, indirectly, because the magnetic will influence the electron to spin, and which will produce electric. And that's where, when we try and tap into it, that's where we have amps. With the amp meter is the wasted energy. When we were using our resistive loads the way we do in our circuits, we're shorting out the dipole, the source of energy. We short it out, and you measure amperage in that case. And that's fine, because you can easily create a very powerful magnetic field. So there's, by definition, the magnetic is equal to the electric if you actually use it. So when you have 8 watts or 1 watt, and you're producing quite a powerful magnetic field that is convertible to hundreds, if not thousands, of electrical watts, when properly converted, transformed to this right frequency that you can use it, then that, it's like undeniable. So here, like I said, by definition, right in the book itself, the textbooks, that you have circulating current. But the problem with the electrical engineer, he's all about electric and not about the magnetic, when he's trying to create efficiency in relation to you know, specific applications. He's all about electric. And a lot of these free energy attempts are trying to work on the electrical side of things rather than the magnetic. So if you can create with a 1/4 watt a very powerful magnetic propagation of waves, why wouldn't you do that where you're, like here, 144 times more circulating power, which is truly radiating out in this direction, that direction, and all around here. So about 70% of the, like if you made a sphere, like I often show at my meetings, like 30 or 40 coils all around, and they're all lit up. And they're not actually running off of the proper loads, but they're just showing you that all that radiation can be useful. And it's not, we're not talking about little tiny useful, we're talking about, like I said, 144 times out from the in. So, you know, that's just with a 1/4 Y input. You know, if I go up, like I said, to 3-4 watts input, then we're talking almost 1,000 watt potential with the bigger coil. So this is just one of many types of systems that are doing this. The motor system is even doing it in resonance. It's the same as the acoustic, and it's permissible when you're talking about sound. It's permissible when you're talking about signal generation. Patents are issued, thousands of patents are issued where there's these kinds of resonant gains, and they're using the energy, but because it's not to create energy, electricity per se, like if you're creating light amplification, it's all there. You know, quite high COPs, when you consider the energy as light, it's acceptable to make a patent and claim that. But when you say, I'm going to make electricity, I'm going to have greater than 1 from my input, whoa. I mean, if it's a solar panel, sure. If it's a wind generator, sure. But if it's collecting another form of radiation, I mean, Tesla had his 1901, his radiant patent, where he put a shiny plate, insulated shiny plate up in the air, and he was collecting the radiation from all the lightning storms and that kind of radiation around. And so the higher he went, the more he got. And so that's just another kind of similar to a solar panel. So what I'm suggesting to people is you can take a fan and you can tap the energy that you're using, and it's not being used, I should say. You can still run your applications the normal way, and now you can tap energy from that, and you can do that fairly easy and get something, which is what I'm all about. I rather do something than nothing, right? So then you can learn, from these two books how to, and study how to do a high Q coil, and make more and more of the mathematical side, figuring out how to multiply the energy like crazy. But I mean, do you really need more than a couple of times more output than input? So I mean, I've been doing these things now, I guess 15 years, and I've done so many different kinds of systems, and I don't really think about it too much. It's not so shock and awe to me anymore. But most people don't get the things that I'm saying in this video. This is the place to start to come to grips with the psychological part of it all. Come to grips with that it's foolishness to deny perpetual motion. Everything's in perpetual motion. The electrons are in perpetual motions and they're not wearing out. The energy is coming from somewhere to keep them all going. However you theorize, the fact remains as that is the fact. And whether there was electron or not, it doesn't matter, because it's all the same. It's happening, and you can't explain it any other way. And it really doesn't matter, because all that people care about is if they have to supply energy or not. If they can take it from the environment, that's great. Like if we can split water too, we can do a resonance process where the water cell is a capacitor, and we have that in resonance, and it splits the water at the right frequency. We don't have to spend all these amps on electrolysis. We have resonance, and so you can create fuel, and that is good for the environment. There's no, the output of that is water. It takes water and it creates water, brings it back together. So you don't have to have all this nuclear energy, all this pollution, and all this waste of money in the world. And that's unfortunate. It's going to be like that no matter what for a long time. You know, there's no changing it right now, and I don't expect to in my life. But I can create awareness to people that you can learn these things. But you've got to come to grips with the fact that do something. Like, don't try and, like a lot of people I see strive to get the big output, and they fail to they miss out on what's right in front of them, what they can do, and they're not willing to come to grips with it because they have maybe skeptics they're trying to prove something to. But if you're not impressed with some output rather than no output, then I kind of not, like I have this group of people that I'm making this video for right now, and I'm not quite sure if they'll receive this or not. And I kind of did this video because I realized they probably are overthinking the whole process and trying to get a goal, and they're not satisfied until they get that final goal. But they really need to come to grips with the fact that they need to see these various things, like in the textbooks, it's already admitting this. In existing technology, it's already doing these processes. It's just that at other points they're destroying the energy, or they're radiating it out and not using it. So first come to grips with that solar and wind is the same thing as these exotic other processes. They're the same kinds of systems. They're just not, you're just not familiar with them. And yet these other types of systems where we're creating a gain here, they are in multitude of products over the last 100 years. People haven't realized it because, again, their purpose is not to create energy generation, but to create a television screen, for example, or microwave your food, or you know, radar, or all sorts of things that are using these kinds of processes. They're creating enormous gain of energy, but the purpose is for another reason than energy generation, to power your own needs. Like the creation of light or something. So anyway, you have to come to grips with those things. You have to not be deceived by the wording and the definition and all the ridicule, all the prestige jargon, and just do something. Keep doing it. Observe it for months and years. Have something, just keep on going, you know, where you're getting something, and then you learn more and you do more, you know. So that's what I'm trying to do, is create a right way of looking at it. And so here's, just to explain what this is sitting out here. So this is a big capacitor that's adjustable. It's like a really expensive, like $300 vacuum capacitor. And then this is a barometer that is an adjustable inductor. So between the two of them, either in a series connection or parallel, is what's called a tank circuit. When you have matching these, whatever, they're both variable, so I can tune both of them. And these are the kind of the essential parts of a crystal radio. And we do the same thing on the smaller scale here. But with the right frequency, I can tune these so they're in resonance. So that's just a bigger version of what we have in one of these here, for those who are wondering. But yeah, I think I've covered everything I wanted to, left out here. So remember this thing here, this is where I like to bring this around and show people that, hey, you don't really understand why this is doing this. It seems to go against what you know in physics, but you see it demonstrated, right? So you see these things demonstrated, but it's still hard to accept it. It's not as easy to understand as this. So I'm trying to go over more of the psychological part of things so that you can come to grips with it. Because I've realized after meeting thousands of people all over the world, talking to them, emailing them, observing them in various ways, that they have to come to grips with some of these things first. Because people have seen so many things, but because they have these intellectual obstacles and insecurities and what have you, and they haven't really dealt with them, they could never really accept what they've already seen. So I'm saying to these other guys right now that I'm doing this video for, that you've got to understand these things that I'm saying in stages, and then you can come to grips with some of the things that you've seen. I think some people have probably seen a lot of false systems or mistaken systems, but probably some of them were real in some measure, but because there was some mistake, people just reject the whole thing. I don't know, but what I'm getting at is that people have all these things against them to succeed in this area, and what I'm trying to do is my best to help people out of those problems. So I think we have a lot more coming with all the kits and all the stuff. There's so much, but you know, this is what we have right now. I mean, we got more than this, but it's really exciting stuff. Anyway, I'm really pleased, really happy. We've got more meetings coming up. I'll be doing a meeting in May. This is 2019 for people who are watching this video later on. So in May we'll probably do another meeting in North Carolina, Charlotte, North Carolina, and we may go back to California this summer again to kind of do the same thing as last year in both places. And then apart from that, I may do another meeting here in Lansing if there's interest at some point. I usually do them every 6 months here. So yeah, I thank you for watching, and hope it helps you out in some way or another.